Hey 7th graders, welcome to video lesson 2.4a. This will be a 3-part series. In each part we will be adding and subtracting equations. Part 1 will be integers, Part 2 will be fractions, and Part 3 will be decimals. Maybe not necessarily in that order, but those will be the numbers. So our essential question is, how can we use the inverse operation to solve an equation? So today we'll be working with strictly integers. So let's get started. If you take a look at the top of the screen, you'll notice that we have a key. Anytime you see a symbol like this, it's a plus in green, that's our variable. And these two should look familiar for when we did the integer lesson. The yellow represents positive and the red represents -1. So let's take a look at our first equation, x minus 3 equals -4. And what we would like to do is model the equation. So there's my x. Since it's -3, I'm going to use 3 reds. Remember, -3 is the same as plus opposite. And then it equals -4. Okay, our next step is to get the green tile all by itself. So we need to remove the red tiles on the left by adding 3 yellows to the right. So what we want to do is take this green tile and get it all by itself. And in order to do that, we need to get rid of these tiles here. So if we take a look, we're trying to create 0 pairs so we can get rid of those red tiles on the left side. So we are going to add 3 yellow tiles on the left, and in equations the equal signs separates the left side from the right side. So if I add 3 tiles on the left and I come over here on the right, I'm going to add 3 tiles. If you notice on the left, it creates 0 pairs. So we're actually going to get rid of these, and we have 3 0 pairs on the right. And what does that leave us with? So everything on the left goes away, which isolates our variable. Isolates means to leave alone. And on the right side, we lose those 3 sets. So that means the remaining tile shows the value for x, which means our solution for x is -1. Okay, we're going to do a few more examples, so if you're a little confused, this is a new skill, so let's work on a few more examples, and we'll do a ton of this in class. We're going to model -5 equals n plus 2. So -5 would be 5 red tiles, or 5 minus signs, equals the variable plus 2 yellows. Okay. Our next step, remember, our goal is to always get this variable by itself. So what's next to the variable are these 2 yellows. And how could I get rid of that? By adding 2 red tiles to both sides. So I add 2 to the left and I add 2 to the right. If you notice, these will cancel out because they're 0 pairs. So we're removing the 0 pairs. These are going to go right here. These are gone, leaving me with just the variable. And if you notice on the left side, I have no 0 pairs to remove because they're all the same color. So the remaining tiles is the value of x. And if we count these up, 1, 2, 3, 4, 5, 6, 7, our value for n is 7. So -7. So n equals -7, or -7 equals n. we're going to use tiles to model x minus 3 equals negative 4. Alright, so we'll have our variable for x minus 3, and then equals, and 4 negatives. You notice that the coloring's not necessarily the important part is just making sure that you use the plus and the minus. Alright, so what we want to do, we want to get the variable tile, which would be this, all on its own. So that means this is the piece that we need to get rid of. So if I have 3 minus, what is the inverse or the opposite of 3 minus? And hopefully you're saying 3 plus. So I add 3 positives on the left, add 3 positives to the right. Now we get rid of all the 0 pairs. So these 3 go, and 1, 2, 3 go, 1, 2, 3 go. So that means my variable is equal to just 1 negative. So that means my solution is negative 1. Negative 5 equals n plus 2. So there's my negative 5s, 5 negative signs, equals my variable, and then 2 positives. So my goal is to isolate. Remember, isolate means to make alone, to isolate the variable. So these are the pieces that need to go. In order to do that, I subtract 2 on the right and 2 on the left. So it looks like this. So here are my 2 on the left and 2 more on the right. Cross out the 0 pairs. If you notice, I had nothing to cross out on the left because they were all negatives. So since the signs are the same, we add and keep. That means my n equals negative 7, or negative 7 equals n. I have 4 examples here for you. What I'd like you to do is try to solve these on your own, and I will go over them for you step by step. Okay, the solution to letter A, we have our variable plus 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is equal to negative 5, 1, 2, 3, 4, 5. Alright, so our goal is to get this variable alone. So what I want to do is minus 10 to both sides. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm strictly using a different color so I show you the steps that I'm taking. If you notice, these are called opposites. So all of these cancel because positive 10 and negative 10 equals 0. So I'm left with x equals, and if you take a good look here, these are all negative signs. I had 5 negatives, I added 10 more, my final solution is negative 15. Okay. For example number 2, we have variable minus 7, 1, 2, 3, 4, 5, 6, 7, equals negative 3. And what we want to do again is isolate our variable. So we want to get rid of these minus 7s. So we're going to add 7, 1, 2, 3, 4, 5, 6, 7, and do the same to the other side. 2, 3, 4, 5, 6, 7. Now we want to get rid of 0 pairs on each side if possible. So all these cancel, leaving you with the variable equals 0 pair, 0 pair, 0 pair. So I'm subtracting 3, and it leaves me with 4 positives. So that means for part B, my solution is 4. For number 5, I'm going to show you letter C. I'm going to show it to you algebraically. Negative 15 equals t minus 5. So if we take a look, this is what we want to isolate, our variable. And what's in the way? This minus 5. So that minus 5 is the piece that needs to go. Well, what's the opposite of minus 5? That would be correct. Plus 5. If I add plus 5 to the right, here's my equal sign. I'm going to add plus 5 to the left. These two pieces cancel out because they're opposites. My variable is now isolated. Since my two signs here are different, I'll subtract 15 minus 5. I get 10. Since 15 gives me a larger absolute value, I take that sign. So my final answer is negative 10 equals t, where t equals negative 10. And for the last one, I'll show you the same way. We have 8 equals 12 plus z. So remember, our goal is to isolate this variable. And what's in the way of that? This 12. So in order to get rid of the 12 to isolate the variable, we take the opposite or inverse. These cancel, leaving me with z equals. My signs here are different, so I subtract 12 minus 8 and get 4. And since 12 gives me a larger absolute value than 8, I keep the negative. So my solution is negative 4. For this activity here, there's two things I'd like for you to do. I'd like for you to provide the equation and then solve it and give the solution. So for part A, there's 4 negatives in here, so that means negative 4 equals, this is my variable x, and then there's 1 positive, so that's plus 1. You can use tiles. I'm going to, from here on out, show you these 4 examples algebraically. Once again, we want to isolate the variable. So in order to do that, we get rid of the plus 1 by taking the inverse. Remember, these are considered opposites. So those cancel, leaving me with the variable equals negative 4 minus 1. Since the signs are the same, just add them and keep negative. X is negative 5. For example B, we have our variable x. There's 3 minus signs, so minus 3 equals, there's 3 positives, so equals 3. Again, remember, our goal is to isolate our variable. And in order to do that, we have to get rid of this minus 3. So we add 3 to both sides. Okay, and remember, these two pieces in here are opposites, so these equal 0, leaving me with x equals 6. For part C, we have our variable x. We have 5 negatives, so minus 5 equals, and here we have 4 negatives. Okay, and if you can answer some questions, our goal is to isolate the variable. So we take the opposite of minus 5, so we add 5 to both sides. Okay, those canceled, leaving me with x equals, signs are different, we subtract and keep the sign of the larger absolute value, so x equals 1. And for our very last example, we have 5 positives, so we can just write 5 equals, that's my x, and that's minus 2. And at this point, I hope we know that our goal is to isolate the variable. And in order to do that, we have to get rid of this minus 2. So we'll add 2 to both sides. 7 is equal to x. Those are opposites, they cancel. Okay, so I hope you have taken some time, copied all these examples down. Please go to your assessment, and if you have any questions, write them down and I'll address them tomorrow. Thank you.